I attempted the first one and my document camera wasn't working, and I figured out, oh, I didn't have the, so they weren't, there's, this is for our Wednesday class, August 24th, try and cover, we actually met today at 2 o'clock on, and I'm assuming that once I got through the syllabus and the charging and your first equation in Physics 220, which charges like energy, there's only sized, because there are, we know of in this universe so far now, when we start unlocking the mysteries of dark matter or something, but there's only, for our purposes, there's only two things that carry charge. Those are protons. Depends on the number that you have in these things. And we found out that the base element, this, in fact, I'm going to write this down. What is the proton and electron? And you can write it -19 coulombs. Okay, and then the mass of the charge, and then our mass of the proton, two masses, their charges are the same. Now, one of the things that 20 compares, some book does not cover this, and that is the idea of how much charge there is in three spheres put together. So that's what I'm going to show you. Then we'll move on to, because I'm hoping we've already talked about charging, we'll move on to Coulomb's law. And maybe tomorrow for the electric field stuff ready for you. And we'll talk about that so that we can do work in class. And you can be doing work in class. Penn and Flersham Hall is not conducive, tricky, to work with your partners and things like that, the people sitting close to you, because it's those 60, 19, 2000 of seating, which let's get to real quick. So I'll turn this off. Sorry, turn this off. I wanted to make sure. Yeah, we still have the recording going, so you can still hear my voice. Now, here's what I'm talking about. What are you talking about, Willis? Well, here we go. All right, let's make this a full screen so you can see. Here it is for Physics 220 August. So this is video lecture 1. And I'll post these notes on Blackboard too. Okay? All right. So video lecture, that's supposed to say lecture 1. All right, so here we go. Now, let's say I've got, and we usually deal in microcoulombs, and because a bolt of lightning is like 15 to 20 coulombs, or 10 to 20 coulombs. All right, and that's a heck of a lot of charge and a heck of a lot of energy. But so we deal in microcoulombs and things like that. So if I'm going to have something, let's say I've got this sphere here. Okay, and it contains -3.5 microcoulombs of charge. Okay, and then I put another sphere here that has 4.7 positive microcoulombs of charge. In other words, it's missing some electrons. This one has too many electrons. All right, now here's what we're going to do. We're going to bring these two together. I'm going to bring sphere 1 and sphere 2 together. Okay, so there's sphere 1 and sphere 2 together. Then in a pretty short amount of time, we're going to separate these two spheres. And I'm wondering what the charge is on each of them. Because the charges should have evened out. The amount of charge should have evened out on both of them. And I'm wondering what the charge is. Well, here is what happened. Okay, here is what happened. We brought them together. Okay, so when we bring them together, these -3.5 microcoulombs of charge go flying over here to where there's an intermediate step. There's an intermediate step where where 1 has 0 charge, and this one, if all these -3.5 comes flying over there, then this one has +1.2. microcoulombs of charge. Okay? Well, here's another intermediate. So this one has 0. This one is now at 1.2 because the negative 3.5 came over. Electrons move. So the electrons start flying over here again. But how many fly over there? And for every one electron that flies over here, this starts to gain positive charge until they're both equal. Okay, so if this has 1.2 positive charge, how many electrons are going to go over there so that they'll both have the same amount of positive charge? How much? Okay, right. So this would be 0.6 microcoulombs, and this one would have positive 0.6 microcoulombs. So algebraically, you can figure out these charge problems by taking the total charge, adding it up, and dividing by the number of spheres that we're putting in contact. So if we did 3 spheres, we just put them together, like if we had, so here's be a second type problem. Negative 1.5 microcoulombs, sphere 2 has 1.7 microcoulombs, and sphere 3 has negative 1.7 microcoulombs. All right, I'm going to bring all of these together. Algebraically, I could just add those two cancel out, and so I wind up with the net charge here, the net charge in the whole system is equal to negative 1.5 microcoulombs after I bring them together. And so when I bring them together, then I separate them. So the net charge in this, they'll distribute themselves out evenly. So each one should have negative 0.5 microcoulombs because I can just divide that by 3. Divide that by the 3 spheres. And there you go. And then another question should be, how many extra electrons are on sphere 1? Oh, well, that's easy, because you know that the amount of charge is equal to N times E. The amount of charge is negative 0.5 times 10 to the negative 6 is equal to N, which is the number, how many whenever you're asking how many, this is N, remember, times 1.6 times 10 to the negative 19 coulombs. All right, so that's not bad. I'm going to stop on that.